Just want to thank everyone for joining. Welcome you to the Energy Storage Market Series. Today, we're going to be hearing from Greg Smith, author of The Battery-Powered Home. Before we dive in with him, and while we're waiting for more people to just kind of filter in and join, I'll give a little background on RENVU in case some of you aren't familiar, and just talk a little bit about products that are maybe relevant to the webinar that we'll be having today, and we'll go from there. So my name's Nick. Like I said, I'm a sales engineer here at RENVU. RENVU was founded in 2012, based out of Mountain View, California, although we now have fulfillment centers in California, New Jersey, and Texas. So we have a reach kind of throughout the entire United States and work on projects regularly in all 50 states, as well as some in the Caribbean and other countries. Our entire sales team has an engineering background, so we like to go real in depth with projects and with our customers and the products that they're working with, be it a smaller residential DIY project all the way up to larger commercial projects. So we've got that baseline level of knowledge to be able to help out design systems and troubleshoot. We do offer additional services, which include the Megawatt Club listed here, which is a great program that allows for free shipping inside the continental United States for a cost of $950 over 12 months at a cost of $950. As well, there are extra discounts that you can get on sales that we offer, permitting services, things like that. Like I mentioned, engineering and permitting services as well. We can work on plan sets, get engineering stamps, do design work for any projects you have. We've got a number of online quoting and design assistance tools, from our solar kit guide through to mutual shading calculators, wire sizing calculators, basically anything you might need. And we do have a number of different financing options that we work with partners for end users to get loans for projects on their residence through to net credit terms or longer bridge financing for larger projects. A couple of the products that we offer that are definitely relevant to what we're talking about today. So right now, the main residential module that we have in stock and ready to ship are the Q-Cells 340 watt AC module. This has the Enphase IQ7 Plus pre-installed in the factory on the module. Paired with that, the Enphase storage system, the N-Charge. We have all those products ready to go, and it's all configurable in our design tool. Some other great hybrid inverter and storage options would be the Humless battery system and the BYD, and those can both be paired with SolarArc or Solus to provide a number of different design options and capabilities for your systems, be it grid interactivity where you want to work around time of use or demand charges, full home backup, off-grid capability, a number of different options there. So it's just a few of the products. Before we dive in and I pass everything over to Greg, I just want to mention that you can find all of our previous webinars recorded on our YouTube page. We'll be sending out an email with this recording as well after we're done. If you have any questions about the products or for Greg as he's going through, please use the Q&A section as opposed to the chat. It just makes it easier for us to organize the questions, and we can get to all of those at the end. Please try and limit your questions as well to sort of product design, those sorts of areas. If you have pricing specific questions on products, you can reach out to us after the webinar at info@renvu.com or give us a call, and we're happy to get quotes together for you. Okay. With that being said, I'm going to go ahead and pass controls over to Greg and let him take it from there.
Awesome. Thank you, Nick. Thank you for that introduction. Thank you guys for logging in to watch this presentation. I really appreciate it. I'm coming at you from my battery powered home. I don't know if you can see it. I'm in my garage here just because I feel like standing up instead of sitting down all the time. This new work from home thing that most people are doing now, is finally got used to it. Yeah, but I don't know if you can see it in the back. I've got a Sonic-Core 10 kilowatt hour completely self-contained unit in the back right there. I don't know if you can like open it up, the camera a little bit, but I've got my unit right there. I have a nice Sunny Boy 5,000 watt transformerless inverter on the other side of this wall. So I've got this cool AC coupled system. I've even got some Tigo TS4s up on the roof. And so I not only, have I been in this industry a while, I practice what I preach. I use the equipment, but I'm starting to steal a little bit of my own thunder here as we go through this presentation. So let's begin. So I started with SMA as their senior technical trainer way back in 2008. I know 2008 doesn't seem like it's that long ago, but for me, especially over the last year with COVID time, that seems like a million years. But I was with them almost 7 years, and I really fell in love with the Sunny Island, right? That yellow battery inverter. And SMA went all around the world doing these off-grid systems. And that's the part of the industry that I just fell in love with, because it was very technical, right? Like you needed to know a lot of stuff to do these off-grid systems, or just, even a grid type battery backup in general. And, solar inverters kind of became this commoditized thing where, you just use a string sizing program, you got it and you're done. And I just like the complexity of these storage systems. So in 2015, I left SMA and joined Sonnen Incorporated, which was the American subsidiary of Sonnen GmbH down in Bavaria in Germany. So I went from one German company to another, and really getting a lot of mileage out of that German Rosetta Stone that I did. And I had a really good time basically with Sonnen as a startup. Like, there was no market for Sonnen here in the US for this particular type of battery. And so SMA, we were focusing on lead acid batteries, but when I got to Sonnen, they had lithium ion batteries. So this was kind of my first deep exposure into that type of technology, and it just went full force. So I developed their training program. I was the training manager for 6 years or so, and developed an online training program to get people certified on the system. And I did that. I launched it in the fall of 2019. And of course, we know at the beginning of 2020 what happened. And it was such a stroke of luck that I had this online program done, because I didn't have to travel. I didn't have to go, to give these in-person trainings. It was done all virtually at a self-paced course. And the course got a lot of accolades from the industry. We put a lot of time and effort into it. But after 6 years or so, I decided to move on to a completely different kind of segment of the industry with Tigo. And I think I've been with Tigo now like 4 months. And so I've gone from this huge, big system, complexity, down to these little module level electronics, right? And I'm learning a lot about them, having a lot of good fun learning about that. So previously to 2008, when I joined SMA, I spent 20 years in the US Navy as a sonar tech, riding submarines. Yeah, there we are on the left in sonar, all that Hunt for Red October stuff. I promise you, we were not neglecting our safety of ship duties for very long, just enough to take that picture. But as you can see on the far right, I had a lot of experience with electronics. And also on all of my shore duty tours, I was a trainer. So I was a certified master training specialist, and that was probably what I enjoyed most. I loved working on the equipment, and I loved training people. Yeah. So I trained every like level of knowledge of person, all the way down to the baby sonarman that didn't even know what sonar stood for, all the way up to the captain of a US submarine who would bring the wardroom in to learn about sonar and the responsibilities of that rate or job. Yeah. So I brought a lot of that experience to the industry when SMA picked me up in 2008. And now in this industry that I've been in since 2008, it's always been some type of technical training, and you can't help but to get into the support side of it. So I was usually the technical, subject matter expert for the companies I was working with. So here I am back at SMA, back in my younger days when my hair wasn't so gray. You can see me down here at SPI 2019. Remember when we used to have those? Like, matter of fact, we should all been at SPI this week in New Orleans, but maybe we'll hit it in 2021. Although I'm still kind of on the NABCEP high. You can see the top left picture. We did have the NABCEP conference in Knoxville about a month ago. So we were lucky to do that. And it's good to see all the people in this industry. I mean, this industry just seems to attract good people anyway. And we just have a really good time when we're all together. Matter of fact, this gentleman here won a copy of my book when we played this game that Mayfield Renewable sponsor. You can see Ryan Mayfield in the back there. So just a really cool industry, and I've loved every minute of it. And so people ask me, they're like, so why did you write a book? And the number one conclusion I came up with was I saw a need. I saw a need for it. And it was actually a buddy of mine that said, man, you write all these really good LinkedIn posts, about the industry, about batteries and managing customer expectations, even though you're not a sales guy, like you understand that so well. And so he's, why don't you put all that stuff in a book? So I started researching it, and I went on Amazon and Barnes and Noble just to kind of see, what the industry had out there. And there wasn't a lot of good stuff about what I wanted to talk about, lithium, right? It was all like off-grid guys, and some of them were just horrible. These books like, oh yeah, here, build an off-grid cabin using golf cart batteries and like things that you can just pick up at Radio Shack and, solder together. I was like, well, you know what, that is not where the industry is going. It's going in a completely different direction. I don't want to tackle off-grid. And in my very first part of the book, I specifically tell you who this book is intended for. Like, I give you the target audience, and it's not that type of installation. And as I started, basically, I just started piecemealing all my LinkedIn posts together. And then it just kept building and building and building from there to where it actually became a hobby during the COVID time last year. Also, something else I got into to kind of keep me sane through that crazy year was barbecue. Man, oh man, did I get good at barbecue. So between perfecting my barbecue skills and writing this book, I took up a lot of chunk of 2020, went it by very fast. The book did launch in June of this year. So I didn't realize it was going to take that long to write and copy edit and market a book. Matter of fact, marketing this thing is even harder than writing it. So I'm glad that I can come out and talk to people about it. And like I said, it's a very, very focused audience, right? And I tried to complement that with the title of the book, The Battery Powered Home. You can see I'm living in one. Foolproof, grid-tied, lithium storage. So I think that is about as focused as you can get. Yep, right there. So the reason that I wrote this was to address some really strongly identifiable pitfalls in the solar and storage industry. I don't know if anybody remembers this game. My boys and I are avid gamers, although this came out long before they learned how to play games. But this particular game is called Pitfall, and you have this little guy who has this kind of whip thing that you can jump over these alligators, right? So I'm kind of using that as a visual here. The first thing, a scorpion down here, the pitfall that I saw a lot, being on the service lines for every company that I've worked for in the last 13 years, was there is not enough customer expectation management when it comes to storage. And I'll explain that as we go. Another pitfall I saw was that people were not properly sizing their energy storage systems. They just weren't. And lastly, there are a lot of myths and misconceptions in our industry about what these things can do, right? Either the solar inverters, the module level electronics, the energy storage systems. And I just wanted to, I don't know, to get that off my chest like once and for all, right? As a matter of fact, the very last chapter of my book is totally devoted to these myths and misconceptions. And it's kind of like, I don't know, like a weird appendix thing. My copy editors were like, I don't understand what this has to do with energy storage. And it didn't. It was just a rant that I wanted to go on. Yeah. But for all of these pitfalls, just little shameless self-promotion, the battery powered home is the way to dispel these. It's a way for you guys, and it's an easy read. But as you go through here, I tackle each one of these things. Matter of fact, I tackle a lot of things, but I really focused on these three areas. And so if you look at the chapters of the book here, I'll just push through so we don't have to sit here and watch all this. But I start with an intro like everybody does, and I start with a basic level of electricity because we all have to be on the same page. And finally, I get around to how all of these things fit together, how the solar fits, how the energy storage system fits together as a whole, so that we're all starting on the same page, right? So these first chapters act as a Rosetta Stone for the rest of the book, because if you don't understand the basic concepts of electrical stuff, and I'm not getting like into three-phase vector like formulas. It's very basic. There's a lot of people that don't know what a watt is, or they don't understand the difference between energy and power, right? And so we have to talk about that if you want to be able to talk about this intelligently. Yeah, I see a lot of salespeople, not RENVU, of course, but I see a lot of salespeople that say, "Yeah, dude, I need a 15 kilowatt battery system." And I talk to them, I'm like, "You don't mean 15 kilowatts, you mean 15 kilowatt hours, right?" Huge difference, huge difference. But once we get through these chapters, we get into the meat, right? There is an increasing difficulty of how this book goes. Yeah. And so now we start getting into sizing these systems, how to properly calculate your loads. And the big thing is, well, when we get to this section down here, the 4 hows, like, well, how big of a system do I need? Well, that has to happen here. And I see a lot of really bad online sizing tools that eventually get people into trouble. Okay? And I've got tons of anecdotes, tons of them, real life stories of this happening. So we just want to make sure we all start on the same page and before we dig into the meat of it. And then by the time you're done with this book, you have a solid understanding of what is going on in this energy storage system. And also I show you how to properly calculate loads and how to set these systems up. Like I took a lot of time to make this as an easy of a read as possible. I throw a lot of anecdotes in there. I throw a lot of humor in there because I know that not everybody geeks out on this stuff like Nick and I, right? Like we have this engineering background. We just love this stuff, but it's hard to talk about it in a way that keeps people's attention. Yeah. So I'm going to focus for this presentation. I'm going to focus on 2 things, right? Sizing systems and then managing expectations. And if you're an end user, right? If you're a homeowner that is looking to buy energy storage, or if you are a designer, or if you're a salesperson for a company that sells energy storage, then this is for you. Matter of fact, the book was geared toward the industry professionals. Yeah. But just between you and me, an inquisitive homeowner will pick up a lot of really good information from this book, right? I didn't specifically call them out because I was afraid that if I said, oh, it's for homeowners and everybody, that the people in the industry wouldn't want to read it. They'll say, oh, okay, this guy just dumbed it down, right? No offense there, but just dumbed it down so the homeowners would be able to understand it. And that is not the case. That is not the case. There's a lot of good stuff in here for anybody. So let's tackle these online calculators, right? And I see this a lot. And I can appreciate the beauty in this simplicity. However, the first time the grid goes down and that storage system flips over to backup mode, there could be some issues with that system as far as how long it's going to be able to sustain that house. Okay, square footage, that's the square footage of my house. They either ask you that or they ask you what your monthly utility bill is. And there are some things that you can infer from this, right? Like, because they ask you for your zip code. So on the back end, they're looking at your zip code and they say, okay, well, you're with PG&E or you're with SMUD or you're with Tennessee Valley Authority, wherever you are, APS in Arizona. And we can kind of estimate for that big of a house, you need this much energy, and they're kind of taking a page out of the whole home generator playbook there, right? Or they use the zip code to find out what utility you're in. And they say, okay, well, we can see that for $350 a month, you're using this much energy. But as I use these, I get two different system sizes when I put my square footage in, and then when I erase that and put in my monthly utility bill. Two different sizes, significantly two different sizes, like they're off by 25%. But I also have an issue with this because there's some things that they're not asking you that are critical. And I've been joking about this for 10 years, right? If you're asking for square footage or monthly utility bill, you might as well be asking them, what color is the house? Because the color of the house makes as much difference to the load as the square footage or your monthly bill. Okay, there's a lot of other things that we have to look at. So let's take a look here. A monthly bill. What they're inferring here is that you're backing up your whole home. Right? That's what that means. You're backing up your whole home. And I should probably write another little small pamphlet or book or something on just how unrealistic that is. Most people, matter of fact, I'll just say the overwhelming majority of people cannot adjust their lifestyle to accommodate a whole home backup. Either they're going to drain the battery or it's too expensive for you to really do the due diligence for a whole home. I'll just tell you that right now. And so you get into this situation, you can see the red areas here are the usable space for an array. Yeah. And so the estimators will say, oh, you need 54 of these modules, and then you need this much battery capacity. Okay, well, that's fine. But if your roof can only hold 20 modules, then that estimator doesn't mean anything. So that's the first pitfall that I get into. Yeah. All right. And so I'm just laying this out there right now. If you do not talk about these three things, or if you don't have these three things baked into your sizing tool for batteries, then you're not doing it right. You're not doing it right. And you are not doing justice to the homeowner. Okay. And they are going to have a bad time the first time that grid goes out. Yeah. I just want to be as clear as possible about that. Matter of fact, just a quick story here. When I was with Sonnen 2 years ago, we had all the fire. Well, I mean, we still have fires now, but last year we had that really bad one, the campfire. And there were people that PG&E said, okay, well, we're gonna cut your power down for 3 days. Well, that 3 days turned into 2 weeks for a lot of people. Yeah. And we had some customers. I was with Sonnen at the time, and we had a customer that had a 20 kilowatt hour system and a 7.6 kilowatt inverter. Yeah. So on Saturday, 1 day into the PG&E outage, these people decided that that was a good time to have a hot tub party. Yep, why not? Let's have a hot tub party. And they drained that battery down in about 4 or 5 hours. We saw it. We saw it on the monitoring system. And because they drained it down so far, they didn't have a generator. They didn't have a lot of sun because the fire and the soot and all that. And they went a long time without power. And I talk about another specific case in the very first paragraph of my book. I open with an anecdote. Now, the names were changed to protect the innocent, but the story really happened. All right, so we want loads. Let's talk about loads. You have to know how many loads you have. And there are 1,000 billion sizing spreadsheets out there. We used to do it pen and paper, and then we used calculators, and now we have Excel spreadsheets. Now we've moved on to these online things, right? So, and I use specific online tools in my book, right? I even use a lead acid manufacturer because they have a really good sizing tool. So we have to know how many of the loads we have. In other words, how many lights do you want to power when the grid is down? How many TVs do you have? You got kids? How many LCD monitors are hooked up to those PS4s? PlayStation, right? We're PlayStation Nation in this house. Yeah. But you can go Xbox, or how many computers do you have? And then we need to know what the power rating is of those devices. And so when you take how many you have times how many one unit consumes, then you get the total power requirement for that device, and you just keep adding them up. And at the bottom of that column, you have the total watts. And the total watts is how big the inverter must be, or how much power that system has to provide. Yeah? So for example, if you calculate you need 10,000 watts of power, and your energy storage system can only put out 8,000 watts, that means if you have all of those loads on at the same time, the system can't support that. Yeah, but that's worst case scenario, right? Like when the power goes down, your first inclination is not to run around and start turning all the loads on that are on in your house, right? So salespeople, this is where the customer expectation management comes in. You can say, okay, we've calculated these loads to be 10,000 watts, but that's if you have everything turned on, right? If you're still smart with your energy consumption, then this 8,000 watt inverter will be fine. And I'm totally cool with that, as long as you tell them that up front. But what I see happen is a year or two later, during the first power outage, the homeowners forget that conversation. And so they call you and they say, hey, my system just went down because I was having a hot tub party, right? It's your fault, not their fault. Now, runtime. When we take the power times time, watts times hours, we get watt hours. And it doesn't take very long for the watt hours to kind of bleed into these, 4 digits, and we have to use kilowatt hours. Yeah. So kilowatt hours, when you add all that column up and you get the total watt hours, that tells you how big the battery capacity needs to be. Yeah. And something that I'll talk about later is where you find the power rating of these devices. And some of them are kind of tricky to find. However, you can find these things online, right? Like, for example, most refrigerators, when they're running, consume about 400 watts, average, 400 watts. And a refrigerator runs for about 8 hours a day, 6 to 8 hours, right? So, but in general, most Energy Star compliant refrigerators will consume about 2 kilowatt hours per day, 2 to 2.5. If you have a freezer, it's about 1.5 to 2 kilowatt hours a day. So let's talk about that. My Sonnen 10 kilowatt hour system my refrigerator is taking 1/5 of that battery capacity in 24 hours. My freezer over here with all my venison and elk and pheasant, that's taking another 1.5 kilowatt hours a day off of that battery, right? So that leaves 6.5 kilowatt hours for the rest of the day. Yeah, so it gets eat up quick, as my mom used to say back in Arkansas. Yeah. All right. So the best thing to do, instead of having this whole home backup where you're backing up the entire main panel and all of those circuits on there, is to just bust out an essential load panel. And you can see here, there's what, 8 circuits on there. I'm a big fan of the Pick 6, right? So you're not really backing up loads. You're backing up the circuits, the wiring that those loads are on. So typically people will back up the kitchen circuit because you want your refrigerator on. They'll back up the master bedroom, the living room for some entertainment, and the garage, right? So that you can open the door when the grid is out. Although in California, they passed a law in 2019 that says all garage door openers have to have a battery backup itself, because the fires came, PG&E shut down the power, and there were people that couldn't get out of their garage. Like, I don't understand that. To me, I would bust down the damn door of the garage before I burned up inside of the house. But maybe that's just too hillbilly simplistic for me. Right? So bust everything out on essential load panel, and this allows you to control the loads, at least more than if you backed up the entire house. Yeah. So we control the energy use with this sub panel. And that sub panel has a lot of names, right? Essential load panel, protected load panel, backup panel. Some people call it a critical load panel. That is incorrect. That is an incorrect term. And I know that I've lost this battle because a lot of people call it critical loads, just like they call the things on the roof panels, right? Those are not panels on the roof. Those are modules. Panels heat water. Way back in the day, we had solar thermal panels which heated water. And then when the solar people got into solar PV or solar electric, they just kept calling them panels, but it's two different things. Yeah. So it's another rant that I kind of go off on, but panels heat water, modules make electricity. Critical load panels are not what people are usually referring to when they call it a critical load panel. As far as the code is concerned, critical load panels have a very specific definition. That's emergency egress lighting. It's a very fast flip over. It could support life support systems. Okay. These battery systems that we're installing, that RENVU is selling, those are not, they're not certified for critical loads, right? So anyway, don't call them critical loads. Okay. Now, let's put some of this into perspective, right? So here's a refrigerator, 2 kilowatt hour. Most lighting in your house is about 1.5 kilowatt hours if you're busting it out on this essential load panel, right? Laptops take about 500 watt hours a day to keep on. Your router, that's on 24 hours. That's about 1 kilowatt hour a day, right? So how much do we have here? We have 2, 4, 5 kilowatt hours. So 5 kilowatt hours a day would eat up half of my battery capacity if I didn't have any solar to help with this, right? So that's the key. It's not only do you need a properly sized battery system, you need a properly sized solar system that will not only charge the loads during the day, but it'll also power those loads. And so the trick is to power the loads in the house and then have this extra power from the system, the solar system, to go into the batteries, right? That's what we want to do. And I know some people, they're like, oh, I don't want to send any power out to the grid, right? Screw those guys. I don't want anything going. So they size this system to not let, any more than 1 watt hour go. Well, when you have a day one of those off days, and then you've kind of really shot yourself in the foot over that, right? To me, I mean, some people, they don't like the utilities, but it never made sense to me to try to screw them over by not sending any power into the grid. Like, to me, that never made sense. Yeah. So let's take a look at some bigger loads. Yeah. A 3-ton air conditioner, 35 kilowatt hours. Yeah. If my 10 kilowatt hour battery was completely full and all I was going to do in my house when the grid went out was run my air conditioner, then it wouldn't take long for that AC unit to pull 10 kilowatt hours. A stove, electric stove, takes 2.5 kilowatt hours for the hour that you run. A dryer takes about an hour to dry clothes, 2.5 kilowatt hours. A 2.5 horsepower pool pump takes about 15 kilowatt hours a day, and you basically want a pool pump to run 8 to 10 hours, right, on average. Maybe more, maybe less, right? So these larger loads are what people have the most trouble with. Yeah, this is what is prohibitive for a lot of people being able to install a system that will cover not only these loads, but the rest of the house. Yeah, and this comes up a lot. It's like, okay, Greg, I've got elderly customers in Arizona, right, where my son is stationed in Air Force, and it's like 112 degrees. Okay, so not having air conditioner in Arizona is not an option. You have to have it. Okay, but there's always other options. Okay, instead of backing up a 3.5 or 4 or 5 ton air conditioner, put a mini split, which is a ductless air conditioner, in the master bedroom, because those things only pull about 4 or 5 amps, right? So now at least they have a cool place to go forever, how long the grid is going to be down. That's not totally draining their battery, right? There's always options. You may not like them, but there's always options. So surge is another thing that we need to look at. This is extremely hard to find sometimes, and I cover this a lot in my book. I even put this table in there when we start looking at nameplates. But surge power, sometimes called startup power, these big loads, they have a lot of inrush current. You'll also see it called. They need a lot of inrush current to start, and then once they start, they slow down to the running current. So it's kind of like when you start your car. If you have a tachometer on your car and you start it, that needle goes all the way over to like 8,000 RPM, and then it slows down to about 1,000. Same concept here, right? But they're pulling a huge amount of current, 5 to 35 times the running current for a split second. Okay, so you have to make sure that your energy storage inverter can handle that surge. And there are not very many out there that can handle air conditioners. There just aren't. And so you have to think about these things. Again, there's options, right? Okay, well, instead of a big air conditioner, let's do a mini split. If your load is close, let me show you one here. So here we have 2 different air conditioners. These are both 4-ton air conditioners, but they have 2 different ratings, right? This one is 64 amps. This LRA value here is called locked rotor amps, and that's the value that you use to determine if your energy storage system can start this, right? So locked rotor amps, 64 for that one, 72 for that one, and they're the same size air conditioner, right? So this is, and you have to pull this out and look on the nameplate. However, if you don't want to do that, if you just want a nice rule of thumb, about 70 amps is what I would say, right? Well, okay, so let's just use this rule of thumb as 70 amps for an air conditioner, because you can't talk the homeowner out of it. They want to use their AC, and they promise you they're going to bump up the AC to like 78 degrees, right? So we'll just take them at their word. But the lock rotor amp rating is what you need to, so, okay, so you look at a nice energy storage system that you're thinking about, and it can only put out 55 amps. Okay, well, 55 amps won't start either one of these, right? But again, there is an option. Okay, and those options are called, oh my gosh, I just lost it. They're basically surge suppressors. Oh my gosh. Anyway, I'll think of it here in a minute, I promise. But anyway, it's just a big capacitor bank. Thank you, Phil. Yes, a soft start kit. Thank you. Totally had a brain fart there. A soft start kit. So you put a soft start kit in there, and that will reduce the amount of current that the load requires to start. And those are very common. And that's something that I will almost always recommend if the homeowner is dead set on using a big HVAC system. Yeah, thanks again, Phil. Yeah, so here I just kind of reiterate what we're looking at here. So here is a max AC power output. And they even call it surge. This is a very popular energy storage system. And they say 6,600 watts or 6.6 kilowatts, right? So if we take the previous two air conditioners and convert that to kilowatts by using current times voltage, and this is one of the things I go over in my book, we can see that the startup requirement is 3-4 times bigger than what this system can actually put out, right? But this is only one of their units, right? So you would have to stack 3 or 4 of their units just to start that air conditioner. Okay. All right. So talk about this real quick. This is a very common question I get. Well, I was going to do storage, but I don't know, man, the ROI just isn't there. Okay. And this is a mindset that we have left over from the solar days, right? Oh, well, if we can't get a 5 to 7 year payback for our solar system, then it's just not worth it, right? And I don't understand that. I don't understand that mentality, right? Because there's a lot of things that we have that don't have an ROI that we have. Yeah, like your car, right? What's the ROI on that? Nobody cares about that. Nobody cares about the ROI on a $200 perm, right? I'm not picking on ladies. I'm just saying there is no ROI. Okay, I bought a master-built gravity-fed 560 last year, right? A lot of money. I didn't buy it because I wanted to make back my money on that, on ROI. There is no ROI, right? So what I want to get, there is a difference between ROI and value. There is. And that's what we need to talk about. And let me tell you, perspectives change big time. Here we see PG&E turning the power off. We see in the Northeast, we see these ice storms becoming more frequent. This is the latest hurricane that plowed through Louisiana. And my sister, she gets it all the time. She lives over here in Pensacola. And let me ask you something. I guarantee you, those people that are in Northern California that had their power cut off for a week or 2 weeks, that had an energy storage system, didn't give a rat's behind about their ROI. I can tell you that right now. They were just happy to be able to charge their phones, to keep their food and beer cold, and have a little bit of lighting and some entertainment, right? That's what it's all about. All right. So the 4 hows, I talked about this in a lot of detail. How much does it cost? How long will it last? How long can it power my house? And how does it work? Those are the 4 hows that you need to answer, or that you need to ask when you're talking about energy storage systems, right? These are the things that I go into a lot of detail, because this means different things, right? Like, how much does it cost? You hear a lot of salespeople, oh, well, it's $800 per kilowatt hour. Back in the day when I worked at SMA, people say, well, you know, SMA is is this much kilowatt, a dollar per kilowatt, but your competitor over here has a lower dollar per kilowatt. And I just, again, that just blew me away, because if you're only using that metric, if you're only using the dollar per watt or dollar per kilowatt hour, you are totally flushing down the toilet all of the engineering, all of the value, all of the company experience, right down the toilet, because of some number that's cheaper than another one. Yeah. So that also like drives me crazy. And how long will it last? Well, that answer, along with a lot of these, like every answer here falls into two words. And I've been talking about this, and if you've been to my trainings, you'll know what I'm going to say. But the answer to almost every storage question is it depends. Yeah? But that's too vague and ambiguous for a lot of people, particularly salespeople, when they're talking to a customer. And as a customer, you would throw the person out of your house if they said, "Oh, well, it depends." Right? So you have to dig into it. So how long will it last? Well, are you talking about warranty period? Are you talking about like how long the system is going to live, for lack of a better word? Or are you saying how long will it last when the power goes out? Because that's different than question number 3, right? All right. So that's it for me. If you have any questions, we'll take them. I'll let RENVU kind of handle that. I saw a couple of them pop up, but I don't know, Nick, I think you wanted to talk about this a little bit.
Yeah, thanks, Greg. So I'm just going to run in a little information about BLicker, the residential carport system that we have available and have been promoting. If you have questions, go ahead and throw them in that Q&A section. I know we've got a bunch in the chat as well. So I'll just run through this, and then we'll start the Q&A section, and we'll go from there. BLicker residential solar carports and canopies that we've been offering over the past probably 6 months to give an option for people who maybe don't have the right roof space for it, or have kind of an alternative area that they want to cover in and provide solar and on their home. So jumping into it, some of the details: it's made here in the United States, designed here in the United States, comes with a 25-year warranty, incredibly sturdy design. I believe right now it's got a base snow load of 65 PSF, but can be upgraded, and a base wind load, I believe, up to 175 miles per hour now, which is those numbers on there need to be updated, because I believe it's been engineered to be a little bit more robust since. Incredibly easy installation. It's designed to be able to be done by 2 people without any heavy equipment. You only need to dig 2 feet for the piers before you pour concrete. So incredibly easy installation, very light on the tools, and again, designed to be done just with 2 people without any heavy equipment. And it's incredibly versatile. Comes with a standard 5-degree tilt. I don't believe we can change from that, but you can always ask us and we can work with the engineering teams potentially. We've had a number of people design it to be used like it was initially designed as a carport, but also as a pergola in backyards for covering, deck areas, or just areas in backyards that they wanted to have shade next to a pool, maybe something like that. There's a few options as far as some additional add-ons. So just to make it a little bit nicer, you can get solar powered lights to put on the piers, so you've got lighting when you pull your car in. You can get T-gaskets to fully seal off the top portion of the array so that you've got a nice waterproof top array. There's a mesh sail that can be put on the back side of the array to cover the back side of the modules, any power electronics you have, the cabling, so that you get a nice clean look. And it's fully integratable with just about every inverter system, battery storage systems, NLX, the car chargers that we offer can all be integrated and attached on the piers. Cabling piped through the piers as opposed to out in the open. So a lot of really great options in terms of add-ons to make it, specific to your situation. As well, for installers, we have a installer program. Very straightforward. You will do 3 installations. You'll submit an application. You'll do 3 installations. After you do those 3 installations, you'll sign a SPA form, an agreement. You'll get $1,000 back per carport for those first 3 you did. And then there's a base 5 carports per month threshold. Although in the beginning, we're happy to work with people as they're building up their pipelines for it. So, we can work out sort of gradual increases in that. But again, that would then be another $1,000 per carport you install per month. So a really great option if you're looking for, a solar carport or sort of pergola type solution for customers. And just we mentioned it at the beginning and wanted to throw it on here. We have the solar kit guide. So if you're looking to generate a bill of materials for a project, really quick, really easy way, log in. You don't have to, but logging in helps because it'll save your project afterwards. Gives you the options to choose exactly what you're looking for. And sorry, hold on one second. My daughter is popping in here. So yeah, some really great options there in terms of being able to do it. Gives you a full bill of materials on the left there as you're working through. If you're logged in, gives you pricing and interest. So cool. Cool. So let's jump into some of the questions. Okay, so let's take a look at some of these questions initially. If you have any more as well, please feel free to throw them in. We're just going to keep going here and kind of taking them as we go. So the first question we've got is from someone who's not signed in, so just as an anonymous attendee, but looks like they've got a research project on off-grid remote communities with a few homes powered by a central PV and battery system. It's a very special case where they considerably oversized the PV and battery, but just wondering, without considering the battery and solar size, what inverter size should be to power a regular home, 1,800 square feet for 24/7 use without having to do load management? Kind of an in-depth question there.
Yeah, and I mean, those are so complicated to answer. Like, and not to be snarky, but I mean, that's my website there. Like, it depends, right? It really does. And you haven't given me enough. Yeah, Brian got it. It depends. You haven't given us enough information, right, to help you. You say everything's oversized. I don't know what that means, right? I don't know how big everything is. So again, it goes back to like the very first part of my presentation. And this, I think you said it was an off-grid. That just adds a whole new element of difficulty, right? Like, you better have generators. And I talk about this, right? I talk about some things that you'll need. Even grid-tied battery backup should probably have a generator. Yeah. So there's too many holes in that question for me to give you a specific answer. I've done consulting work, and I had a guy that wanted to he was up in Portland, and he wanted to have me design a system that sounded kind of like yours. Right? And I'm looking, and he had this load. It said laboratory equipment that was 55 kilowatt hours a day. I was like, dude, 55. Like, and so I was like, what is this lab equipment? What is that? He goes, oh, well, I started growing weed, and those are my grow lights. I was like, oh, okay. That's a completely different setup, right, than what I would normally have told him, right? But when I gave him the answer, when I gave him a system size, it was a couple $100,000. And I told him, you don't need lithium, you need to go lead acid for this. And it totally like crushed his soul, right? But at least I was upfront with him, and I said, if anybody else gives you an answer that's like way off, way cheaper than this, then I would kind of question that, right? But sir, you're getting back to yours. There's too many variables there, right? There's way too many variables to give you an honest answer. Yeah.
Yeah, I think that's exactly a great answer, and it tied back into the beginning of your presentation pretty well there. So I would say reach out to us and maybe we can talk with you more in depth and start going into the specifics of that project and start looking at all the different variables. Cool. Moving on, Carrie Baker asked, do you have a spreadsheet that has all the metrics needed to size a solar and battery system properly, watts, watt hours, surge, etc. for house loads? I'd be willing to pay for a downloadable version.
Oh man, that is not necessary. I do have it written down in my book, but of course, even in the digital section of my book, you can't use it as a spreadsheet. But I'll tell you right now, if you just Google battery sizing spreadsheets, you will get 100 billion thousand hits. Yeah, and you can just download one, and you'll be good. Yeah, it doesn't take a lot of like computing power to do this. Trojan Battery, if you go to their website, and this is brilliant for them, they secured batterycalculator.com, I think, is their website, and just brilliant guys. And I know a lot of people that work over there. They have a nice, simple system that I talk about in my book if you want an online version. But if you want something to download, just Google that and you will find something that you will not have to pay 1 cent for.
Excellent. Robert Mellon asked, where can we buy the book?
Oh, yeah, absolutely. I know you can't see it right there very well, but it is on Amazon. And it was the #1 bestseller 2 days after it came out. It's still on Amazon. If you just, matter of fact, you either type in my name or the title of the book, you'll get right to it. And I would ask if you, and I'm not trying to tell you what to write, but if you could just leave a review of the book, I would really appreciate it. Amazon, I found out that they just do some weird things when people start putting reviews in, because I know at least 50 people have written one, but I think only a dozen have showed up. So I don't know. Don't know why that is, but yep, it's available now on Amazon.
Great. So next on we've got Terrell Parhams saying Florida product approval numbers, and I'm not sure the specifics on that. So we may need some more detail. So Terrell, maybe if you want to punch in another question with some more specific information for that.
Yeah, there's a lot of places, right? A lot of states, a lot of jurisdictions, a lot of authority having jurisdiction. Those are the people that have to inspect and approve your interconnection. They do have some requirements, right? So this is not a vendor specific book. So that question may seem more like a RENVU question where they're asking like, is the equipment certified? Or maybe he was going along that route. Or maybe he's looking for part numbers. I don't know, but yeah, that's a little vague.
Yeah, for sure. So next question, we've got Timothy Quaritch. What happens to the battery? And I guess the inverter would probably be the thing if the load is exceeded.
That's an awesome question. So there's a couple things that are going to happen depending on the manufacturer. Okay, so and it depends on what you mean by overload or used it for too much. So for example, if you have like what, and for example, my unit here, this Sonnen Core, if matter of fact, and I'll bring my computer over here just so you can see it. Yeah, maybe when you watch it, you can blow up just my camera view to see it. But and let me make sure I'm showing the right thing here. There we go. So here's my Sonnen Core, 10 kilowatt hours. Here's my essential load panel. Okay, everything in my house, every circuit in my house is on this sub panel. And I know that totally goes against what two teenagers in the house, I can still do it. I mean, it takes me a club to do it, but I can do it. Yeah. So The only two circuits that I do not have on that sub panel are my air conditioner and my electric dryer. Those are still on the main panel. But if I did have my air conditioner breaker, that 2-pole 30 amp breaker on this, and the air conditioner kicked on, it would exceed the output rating of the power electronic inverter that's on the inside of this, and the entire thing would trip off, just like a circuit breaker. So that means if the grid was down and I had this thing try to start my air conditioner, my whole house would go black. So I would have to turn the air conditioner breaker off first, then go out and restart my battery system. If you are talking about, well, what if you can, so for example, okay, you can give 6,600 watts. Remember the previous inverter that I showed, 6,600 watts, or so that's the surge, but a lot of them have like 30-minute ratings, right? So your question also lends into this, right? Okay, well, if this thing can put out like 6,000 watts for 30 minutes, what happens if I go past 30 minutes with 6,000 watts? Well, the same thing is going to happen. The system is going to go into standby. Everything won't turn off. It's just going to go into standby. And then the last part of your question is, well, what if I have 10 kilowatt hours and I use up, most lithium ion systems are not going to let you use 10 kilowatt hours. They stop at like 90%, right? 95%. Well, then what happens when I get there? Well, then your system is going to go into standby to protect against a deep discharge. Good question.
Excellent. That's a great answer too. We had someone in the chat, I think, talking about depth of discharge. They didn't go too in depth, but maybe if you want to just talk a little bit about depth of discharge for lithium versus lead acid.
Yeah. Yeah, sorry, Nick. Yeah, that's another good question, right? So depth of discharge is this term that's left over from the lead acid days, right? So typically for lead acid, and depth of discharge is just the inverse of state of charge, right? So it's like your phone, right? Look at your phone, the number that's up at the top, that is your state of charge. So if your phone says 20%, that means you have 20% capacity remaining. The inverse of that is depth of discharge. Depth of discharge tells you how much you've used. So while state of charge would be 20%, your depth of discharge would be 80%. Now, typically for lead acid batteries, they don't want you to go past 50% depth of discharge. So when you are sizing for lead acid batteries, when you get your system sized, if you need 10 kilowatt hours of lead acid capacity, you actually have to buy 20 kilowatt hours. You have to double up. And then you also have to divide that by 0.8 for this efficiency factor. So it gets a little bit bigger than that. So maybe you're buying a 12 kilowatt hour bank. And then you say, well, I want 3 days of autonomy. In other words, I want to run just on batteries for 3 days. Okay, well, now you're over 60 kilowatt hours in lead acid batteries. And so and that may be cost prohibitive, right? So for grid tied lithium systems, we don't use depth of discharge except in one area. Okay, in one area for lithium, you see depth of discharge, and that's on the spec sheets, and it's usually tied to the warranty, right? So they say, 10 years, 10,000 cycles, 100% depth of discharge, or 6,000 cycles, 10 years, 90% depth of discharge, which means they only allow you to discharge the battery to 90%. But what a lot of them do is they bake that in. Even 100% discharge, here's the dirty little secret. I like, shh, don't tell anybody. But when you see a battery manufacturer that says 100% state of discharge, what they're saying is you can use 100% of the usable capacity, right? So for example, you may have a 3 kilowatt hour lithium ion battery module, right? 100% depth of discharge. So you could use all 3 kilowatt hours of that one battery module. However, the nominal capacity would be like 3.5 kilowatt hours. So they have this 0.5 kilowatt hour factor that's invisible to you, but it helps keep the battery on so that when there comes a time that it can charge the batteries, either with solar or a generator or the grid, that the battery system is still awake enough to use that source to charge the battery.
Excellent. I think that's a great answer. So kind of piggybacking off that, there were a couple of questions that jumped into comparing lead acid versus lithium. When would be appropriate to use lead acid versus lithium, and going into a little bit about the different chemistries in lithium. And
oh wow, woo man,
it's a couple of big questions, but
oh, we're getting the good stuff now, huh? And I cover these in a lot of depth in my book. So I'll give you the teaser. I'm not ripping on lead acid. Okay, lead acid is a very good choice for off-grid batteries, for off-grid systems. Yeah, they are very highly recyclable. Right, 100% of the lead in a lead acid battery can be recycled to make a new lead acid battery. Yeah, they're very durable. They're great for off-grid. For grid-tied systems, depending on the type of lead acid that you have, and there's different types, right? We've got lead acid, flooded lead acid, we've got gel, AGM, and each one of those is engineered chemically for a specific application. Yeah. And depending on what you get, lead acid batteries, they need a little babysitting. Okay. They need some babysitting. And most residential homeowners don't want to have to deal with that. Right. So lithium is, and it's not emerging anymore, it is the preferred choice for residential grid-tied systems for a lot of reasons. Yeah. And again, not to rip on lead acid, but the market has clearly shown that lithium is the preferred battery because it's all self-contained. They require no maintenance. Yeah, they are very good. Like they can take a beating. They have high tolerance to higher temperatures and tolerance to lower temperatures than lead acid. You can use more of the capacity, right? It has a smaller footprint, so it takes up, less of your garage or your mounting surface than if you were using lead acid batteries. Yeah. But you never get something for nothing, right? And I've been preaching that for 13 years. The lithium ion, and that's a different topic. I'll get way off if I start talking about that. But the lithium ion chemistries, there are two basic chemistries that we use in residential or even commercial energy storage system. There's about 5 or 6 out there, depending on what source you use. But the ones that we've settled on for energy storage are lithium iron phosphate and nickel manganese cobalt oxide, right? I know that's a mouthful, so we just shorten it to NMC, right? And these are the two dominant chemistries that are used in the industry right now. And there's pros and cons to both of them, right? NMC batteries are typically used in electric vehicles, right? That you would put right under RENVU's cool carport, right? And dude, Nick, I love that thing. If I didn't have a freaking tree out here that drips sap all over my freaking driveway, dude, I would scoop that up because I put my $100 down on a Rivian. And then I put another 100 down on a Ford Lightning because I don't know which one I want, but I've been dying for an EV truck, right? So anyway, the NMC batteries are used in electric vehicles, and you have the Panasonic ones, which are used in the Volt. They're also used in LG Chem. And then, of course, the Powerwall are also used in the Tesla cars, right? And it was just a great economy of scale, right? They're like, well, the gigafactories are pumping out millions of those little cells, right? They're about the size of a AA battery, give or take. So why not just put them in an energy storage? Why not put them in this Powerwall and just hang it up on the wall, right? Economy of scale. They're paying pennies on the dollar for those things. Lithium iron phosphate is a different chemistry, and they use the same size cell sort of. And lithium iron phosphate, what we're talking about is basically the chemical makeup of the guts of those batteries, right? Specifically the cathode, right? Without just getting too geeky on it. But iron introduced a very stable component into these batteries. NMC has a lot of exotic metals. It's really good for specific applications. However, it doesn't have the longevity or the safety that lithium iron phosphate has. But I finally got the people at Sonnen, the salespeople, to stop kind of harping on that. And Sonnen had this video where they showed a nail going into an NMC battery and an LFP battery. And when they did the NMC battery, like it exploded, right? Because you're shorting everything out. The LFP battery just kind of smoked and it got hot. Okay, yes, that is true, right? But that is not a representative example, right? These systems are safe, and the code does not make any delineation about chemistry, right? And there are certain codes, even here in California, where they're so scared about these things that they want to have them not installed even in a garage like this. They're trying to get them installed only outside, right? And it's getting to the point now where, you know, you're going to have to install these things in the middle of your backyard on a catapult. So if it catches on fire, they're just going to launch it, you know, into the nearest lake, right? And it seems like an extreme knee-jerk response to the very few fires that are caused by these systems. But was it the Leaf just recalled all of their cars, right? Like that doesn't help our industry. Yeah. But there's just a certain amount of risks that we live with every day, right? And I think 2020 has shown that. And so I don't harp on the safety factor of NMC versus LFP because I just don't, right? It's not, to me, it's not kind of a fair representation of the overall technology. Yeah. However, there is some very basic things that differ, right? LFP has a significantly higher cycle count than NMC, right? So you just have to bake that into your design.
Great answers, great overview. I think we're pushing towards about 15 minutes past the hour. So I think we're going to take one more question in here, which I think is a pretty good one. And then just to address all the other questions, we'll have a list of this with your contact info. And we'll have the questions from the chat. So any questions that don't get answered, we'll pull in and we'll reach out to you and hopefully have some answers for you. But the last one on here that looked pretty interesting was from Mark about input on new smart panels from Span or Lumen, or basically panels or devices that allowed you to shift loads dynamically. So you can back up your whole home. And then if you want to power one versus the other, you can sit there or set up, you know, cascading you know, levels for shutting stuff off as you go.
Yeah, those things are incredible. Like I saw them, the Span I saw at SBI 2019, and it's so good to hear like audience, you know, talk about that, because I think those are an incredible addition, right? It does add cost. You know, either if you put it in for a main panel, you just can't swap a main service entrance out real quick, right? But it provides an added level of protection against deep discharges. So if you don't know what we're talking about, you hear smart panel, you may be thinking something on the roof, right? That's not what we're talking about. We're talking about these, right? This type of panel here, right? Right here. Now this is just a square D panel, but Span and some other ones have smart panels with smart breakers that can be remotely controlled, like with your app, or you can program them in, right? So the benefit to that, and matter of fact, Sonnen even has a product called the Eco Links that works directly with those types of panels in home automation networks. Like, it's incredible. We've whittled down the customer base, significantly to that type of person, right? That would, those things are expensive, man. 75 grand is a lot for a battery, right? But it does so much, yeah? But what these smart panels do is allow you to cascade those loads off and on, right? Or remotely control them. And you could program it, hey, when the grid goes out, I want you to turn off that, and only leave this on, right? Hot water heater, turn it off. And then, like after a couple of days, when the family starts to really getting ripe, you can just say, okay, everybody line up. We're going to take a shower. Bam, you turn the thing on your phone. It turns the breaker on. You start heating up the water and you just run people through. And then when everybody's nice and clean, bam, you turn it off and you just saved a tremendous amount of energy and you've extended your autonomy significantly with these smart panels. Yeah, I wholeheartedly agree. If you can bake that in to the quote, or at least explain why this thing is so good, if somebody wants a whole home backup, I fully support that. That is an awesome thing. Great question. Thank you.
Excellent. Great answer again as well. Cool. So I think we'll go ahead and wrap things up there. Again, like I said, any of the questions that are in there, we'll be able to pull out and we can reach out to you afterwards. If you have any questions for us, you can send them over to info@renvu.com. Greg's website's right there, snarkysolarguy.com. Grab his book. Like he said before, it's available on Amazon now. I want to say thank you again, Greg. Great presentation. I think we hit on a lot of really fantastic topics that we haven't really hit in any of our previous presentations. And yeah, I think it's been great.
Awesome. Thank you so much. And I appreciate you guys reaching out to talk about this. Anytime I'm available. And thank you everybody for logging in. I know we went kind of long, so I appreciate you sticking it out. If you buy my book at the next solar show, just bring it and I'll be happy to sign it for you.
Excellent. Cool. All right. Well, thank you again, everybody, for joining. Thank you, Greg. And we'll see everybody next time.
I know.